you'll see that the systems sometimes are more set up for, again, what we call as elimination. And as we can see here, and hopefully again this just kind of jogs your memories, that with the elimination method, elimination here is where you've got things nice and neatly lined up vertically. Okay, it's not got a variable already solved for itself. Okay, you guys notice that? Okay, you don't have a variable already isolated. Okay, what we have here is, if I take a look at this, I don't have anything close to having x equals or y equals. I'm not going to waste my time rearranging this to then use the substitution method. I'm going to tackle this by what we say is elimination. So to do elimination then today, you also might hear it be called linear combination. We call it the combination method too, because what we're going to do is combine these two equations. And when we combine these two equations, well, something's going to eliminate. One of the variables will eliminate. So if you hear it called the combination method, it's the same thing. Okay? So what we want to do though is for this, when we combine these two equations, we're going to combine them. We're always going to add them together. When we add these together though, what we want to happen here is one of the variables to eliminate. But in order for it to eliminate, we want to look at these coefficients on the x's and the y's. And we want to have what we say is additive inverses, or opposite coefficients. When you take an additive inverses and they add together, they should eliminate to 0. They should cancel out. All right, the opposite coefficients. And right now, if we were to do this, don't write this down at the moment. If we were to add these two equations together, that's what you've done before in the past, hopefully. Don't write this down. What's negative 2x plus 4x give you? Yeah, and what's 7y minus 2y give you? And what's 5 plus 14 give you? Something was supposed to eliminate. Did anything eliminate? No, because what we have right now is not working for us. None of the coefficients there were opposite coefficients. We see additive inverses. So we have to do some manipulation here. We have to change some things around so that we can do this. It's kind of similar to where we have been working on throughout the school year about clearing up fractions, making those fractional equations, making those integers so that you don't have to work with fractional equations. It's very similar to that. So we got to do that. When you look at these x's and y's up here, is there like one of those variables on the x's or the y's that you're like, oh man, that was so close. If this was only flipped to become something else, the x's or the y's would eliminate. The coefficients would be opposites. That'd be good to go. Anybody see that one of the x's or y's are almost there? What? The x's are, right? Says Eva. If this negative 2x and this 4x, what do these need to become? This negative 2x needs to become a what? A 4. This negative 2x needs to become a negative 4x. If this was negative 4x and this was a 4x, what's going to happen then? Smooth. That's going to become a negative 4x. They're going to what? Cancel out. Right. They're going to eliminate. All right. So what we're going to do then is we're going to take that top equation and we're going to multiply it so that by some number so that they will then eventually eliminate. So then question 2 is, all right, we're going to make these 4x's. What times negative 2 makes that become a 4? 2 does. We're going to multiply both sides of that equation. Everything in that equation gets multiplied by 2. Left side, right side, everything gets multiplied by 2. And that's the same kind of idea we did when we cleared out fractions. The same kind of idea. Okay, multiply everything by 2, guys. Top equation. Let's rewrite it. What do we got? Negative 4x. 2 times 7y. And 5 times 2. Okay? So what we're doing then is we're taking that top equation, and in this case we are doubling it, aren't we? And by doubling it, what did that do to our x then? It made it negative 4x, didn't it? All right, don't touch that bottom one. Don't break it. It's good to go. Slide that bottom one right on down. And now that's our sweet spot. Now that's where we want to be. Now we can take our two equations and combine them together. Now we can add them up. Because now what's going to happen? Those x's are going to eliminate. They should always eliminate now. Eliminates, they're gone. 14y minus 2y is 12y, and 10 plus 14 is 24, right? And it's a quick solve. What do we got to do to solve for y? Y is 2. Okay? Again, sophomores, we did this last year in Algebra 1. You should have done it in 8th grade. My freshmen, we should have done this again in 7th grade and 8th grade, and we're reviewing it now. Okay, after that, go pick an equation. Let's go plug in y is 2. Top one, bottom one, it does not matter. Now here, it's not as quick as substitution. You're going to have to work for it. You're going to have to work for it to find x. It's not as quick as substitution was yesterday. It just never will be. So it doesn't matter. Top or bottom, somebody pick one. Bottom, cool, I don't care. Top one, it does not matter. Let's go with the bottom one because that's what I heard. Y is 2. So 4x minus 2, you just locked in y is 2. And there we go. You're going to have to do usually about a two-stepper. Usually elimination turns out to be about a two-step equation you got to solve. Okay? Well, what is 2 times 2 give you? 4. And again, it's about a two-step equation you got to solve here. Okay? What do we got? Add 4. 4 plus 14 is what? 18, right? And then lastly, what do we got? Divide by 4, and 18 divided by 4 is? It's a nice terminating decimal, isn't it? What is 18 divided by 4? 18 divided by 4 is what? 4.5. Okay. So I'll take the decimal. It's a nice terminating decimal. I'll take the fraction. It's a nice fraction. Okay. The terminating decimals here, that's fine. If it's not a terminating decimal, please don't give me that rounded though. Okay. Like anything we do. Answers again are typically written as a order pair. 4.5 comma what? 2. Okay. So here's the thing for today with elimination then. If it's not got what we say is additive inverses on one of the coefficients, you got to make it. Opposite coefficients is where we need to be with elimination. All right, let's go. Next one. Do we have anything ready to go yet on the x's or the y's? Do we have opposite coefficients there? Yes, no? No. Now on the last one, we eliminated the x's. How about letter B? Which one do you want to tackle then? X's or y's? Y's. Cool, let's go at it. It doesn't matter. It's totally your call. There's no right way, there's no wrong way. Now there might be a more efficient way, but there's no really right or wrong. Okay, I heard the y's. We have a 14 and we have a 7. What do you want to go make that y's become? What's some number that both 14 and 7 divide into? We want to make those 14s. So what we want that to happen here is you're asking yourself, 14 and 7 is currently what we have. What is the number that both 14 and 7 divide into nicely? And that answer is 14. So we want to change these over to a 14. Now currently I have a 14 up there, don't we? Mm-hmm. Top equation, don't touch it, don't break it. It's good to go. It's that bottom equation now we want to flip. Okay. What times 7 gives you 14? 2, I heard. So I'm going to multiply that bottom equation by 2. Okay. That top equation, it's good. It's ready to go. It's that bottom equation you want to multiply by 2. Because multiplying by that 2, what's going to make that y become? It's going to make that y become a 14. All right, let's do that. Let's take that bottom equation and multiply. What do we got? 8x plus 14y. And again, this is maybe where your calculator to watch your arithmetic. Negative 36. Take that top equation, bring it on down. Okay. we are good to go. Why are we good to go now? What should happen here? The Y's are what we were targeting. Do the Y's have? Yep, thank you. The Y's should eliminate. So straight down we go. Add them up. 8 minus 3. And the Y's eliminate. Here's where the silly mistakes happen though. Negative 36 minus 4. Negative 40. Right. Negative 36 minus 4. Negative 40. The first step right then, when you combine those two equations, it's usually quick divide. But x equals, what is that, negative 8? Go to one of the originals, top or bottom, pick one, I don't care. Top or bottom? Top, thank you, I don't care. It does not matter. Sam said top, thank you. So top one, x is negative 8. Plug it in for x though. And go solve y. Okay. Unfortunately, again, elimination maybe is a little bit extra work because that second variable always will be able, you're going to have to do solving on it. There's just no way around it. Suck it up. Okay. Negative 3 times negative 8. 24. And it's a two-stepper. Okay. Typically, a two-stepper is what you got. Not always, but typically that's what you got. Subtract that out. Watch that arithmetic. Negative 4 minus 28. What's we got there? Negative, I think 32. Nope, sorry, I can't add. Try negative 28, right? My bad. Don't do what I just did. Negative 28. Try that again. And then divide by negative 14, and what's somebody got? 2. And finish it off. What do we got? Negative 8, comma 2. Try that again. Okay. Now I have a follow-up question here. These follow-up questions, we've seen these bits and pieces throughout the school year, where we've done some things like this in geometry, and I've thrown out some of this here, where this is an SAT thing, where yes, you got an answer, but SATs sometimes will like to ask a follow-up question here. What's the product of x and y? So SAT will ask you sometimes what's your solution, and you're done. But then SAT will sometimes not necessarily ask you what's the solution, but SAT will give you, hey, this system like we solved, but instead what they're going to ask you sometimes is, what's the product of x and y? So what's your answer going to be? Right. So you got to realize, what does it mean to be a product? Product means what? Multiplication. And then you got your solutions here, right? You got to realize what you just found. X is negative 8, y is 2, product is multiplication, negative 8 times 2 is negative 16. So you're going to then type that in, choose multiple choice answer, whatever the case is. But SAT likes to sometimes throw this out there where they're going to take that one step further, where they're going to ask you to make sure you're reading carefully and also bring in that vocabulary of what's product mean, what's quotient mean, what's the sum, those type of things off that. Okay, so just a heads up as we work through here over the next couple weeks. I'll keep throwing a little bit about that with there. Okay, next how we go. Let's do a couple more here, and we'll call it a day. All right. I want to drop down. I want to do. Let's see. Let me watch my time here so I can give you guys some time to work. Yeah, let's do down here 3B. 3B. Okay, 3B. It's a jumbled mess now. What method would you try to end up using here? Substitution, elimination. I would probably aim for substitution as well. We saw this yesterday, right? We saw this yesterday. This is y equals y equals. Now what's the difference also on this one? As we set this equal to one another, what do we have as we set this equal to one another? I'm going to plop this down right in front. Okay, it's a substitution. I would definitely agree with you. We saw this yesterday. But let's go into our tool bag of equations. Are these linear? Now what do we have? You gotta kind of change your thinking here. We're in quadratic territory. So we have 3 methods now to solve quadratics. Square roots, factoring, and what else have we learned this week? Quadratic formula. So you now have 3 tools in that quadratic tool bag. And all of those we need to put in standard form. So let's start kind of rearranging things. But as we start rearranging things, I said standard form, but let's think here. I'm going to subtract that x squared, right? I'm going to subtract that x squared to combine it. But I said standard form is where we usually go. Do I really need to go that whole route to standard form, though? No. What am I going to do here? I'm going to square root this thing, yeah. I said standard form is usually the route we go. That's if I'm going to use factoring or quadratic formula. If I'm going to square root this thing, which I'm hoping we've done a shit ton of those, sorry guys, but we did a crap ton of those throughout the school year, you should realize I don't have a linear term up there. You should know that we are solving this thing by square roots, okay? I don't have a linear term up there. I'm absolutely going right to my tool bag of solve this thing by square roots. I can square root that thing now that I have an x squared there. And what's my solution then? And thank you for saying plus or minus 7. Typically, one more time, how many solutions do we get? 2. A positive 7 and a negative 7, don't we? Okay. So if it was a linear term in there, we're going to standard form. We're factoring it. We're going to use the quadratic formula, one of those 2 options. Here's where things get interesting. Okay, we have a positive 7, we have a negative 7, don't we? We're going to write this up. We found the x's, didn't we? What variable have we not found yet? We haven't found the y, have we? But we have 2 x's, don't we? We have to count for what? Possibly 2 y's. Why? Because, well, we have a positive 7. Let's go back into either equation. Okay, 7. If x is 7, what is y equals 2 times 7 squared get us? So when x is 7, you're going to have to evaluate that. Okay? And when x is negative 7, you're going to also have to account for that one. And when we do this, and we try to beat it into you through Pythagorean theorem, here through quadratic work, you better be using those parentheses. Now that's just straight up with your calculator. You don't have to really mental math it, you can. 49 times 2 is 98. Does it matter on the other one here? It's going to give me another 98, isn't it? 2 negatives make a positive, times the 2 is another 98. Yes, you get the same output. The reason why we're going to get that same output is that U-shaped. Okay, we're having that symmetry happen. So we're going to still get that 98, but for 2 different inputs. Okay, so we do have to account for in that quadratic solutions here, that positive 7 and negative 7, give me that 98. Okay. Now, off of there, I wanted to finish off that last one here with you. Then I'm going to just show to give you some time to work today. Okay. But it's a good one to talk about. I'm not going to emphasize anything more with that, but it's a good one to throw out there, bringing back in our square roots, tied into our systems. I would love to keep talking more with that with you when we come back from spring break, but we're going to switch gears a little bit back to some geometry stuff. Okay. All right, give me some time to work, so I'll shush. Chloe, give me 1 second, okay? I will definitely.